So over here we will draw trigonometric functions. So we have already discussed these terms, that whenever there is a change in the function, the whole graph will compress or stretch along horizontal axis. Let's say if we make this type of changes in our function, over here the graph will compress or stretch along horizontal axis. See over here the graph will stretch along horizontal axis, and over here the graph will compress along x-axis if the function is of this form. But if the value or is outside the function, or let's see as another example, the graph will stretch in this form along y-axis, and over here the graph will compress along y-axis. So you can see that this is the example of this type of function. So the graph will compress along x-axis. So we know about the compression and stretching. We can move on towards the period. What will be the period of this function? We will check the period by just dividing the 2 pi by 2. The period will be pi. We know about the original graph of sin x. That's in this form. But the graph of sin 2x will be in this form, and the period will be pi. But you know that the period of sin x, it starts from 0 and ends up at 2 pi. But the graph of sin 2x will end up at pi because the period is pi. Okay, let's see another example. That is cos pi x. So first of all, you can see that there will be again a compression along horizontal axis, and next we have to find out the period. That will be 2 pi over pi. That's 2 is the period. So our graph will end up at 2. So we know about the graph of cos x. It ends up at 2 pi, starts from 0. But now over here we need to draw the graph of cos pi x. That will be in this type of form, and the period will be 2, and so it says that the ending will be at 2. So that will be 1. You know that's the missing point. All right. Let's see some other examples. So over here you can see that that will be again a compression along x-axis, but there will be a reflection. You know that whenever there is negative sign outside the function will reflect along horizontal axis. But when there is a negative sign inside the function, that will reflect along y-axis. So we have seen this whole thing. And the third part will be of finding the period. That will be again just dividing 2 pi by 3. What will we get? So 6 is the period. So we know about the original graph of sine x. It's in this form. It ends up 2 pi, but now the function is sine pi by 3 over by x. So we can draw, and we know about the period, that is 6. And we have to draw, reflect it along the x-axis. So the graph will be in this form, and it will end up at 6. Or you may say that's the midpoint, that will be 3. Okay. So let's see some other examples, the more complex ones. Okay, so we are done with these two. We'll see this one. Okay, cos x minus pi by 2. So we have already learned this, to add this thing too, that whenever we add or subtract anything inside the function, for example, to a factor of this and with a factor of e, the graph will move to the left side, and over here the graph will move towards the right side. But when we'll add something outside the function, the graph will move upward. But when we subtract something to the outside the function, the graph will move downward. So over here we can see there is an okay, so the thing that involves over here is of this type. So we'll move our graph to the right side to the factor of pi by 2. So we know about the original graph of cos x, that's in this form. So we have to move it a bit to the factor pi by 2 that lies over here. So over here there will be pi, this will be pi by 2, and that would be pi by 3 pi by 2. Okay, we have to move it a bit to the pi by 2 factor, like this. Or you may say that starting point of cos x minus pi by 2, that would be pi by 2. And okay, we may draw this type of graph again. Okay, if you want to find this vector, and you know that the difference between these two vectors, this two vector is of pi by 2. So again, if you want to find out this vector, you just add pi by 2 by pi by 2, you will get pi, that will be pi. And again, if you want to find the next vector, you will find that will be 3 pi by 2 again. You can easily find out the rest of that values. Okay, let's move on towards our next question, that is sine x minus pi by 4 plus 4. So we have to check along horizontal axis and y-axis too. So over here we need to move it to the right side and move it to the upper side as well, to the point, to the factor of 1. So we know about the original graph of sine x, that is in this form. So we have to move it a bit by using this factor sine x minus pi by 4. And we know that in the original factor, we do have this is the middle point. pi by 2. So over here that pi by 4 will lie. Okay, so we have to start our working from this point. So that will be in this type of okay. So our graph will start from this point. So you can see that we have to move it to the factor of 1 as well to the upper side. So what will we do? This will be the axis. And we have moved this whole because we know that this will be the 1, -1, and this will be the 0 and this will be the 1. We have to move this whole section to the upper side that consider as the 1 section. So this again starts from here, pi by 4, and we can add a pi by 4 with pi by 2 to check our next value. That would be 3 pi by 4. Okay, the midpoint would be 3 pi by 4. Or you can just check that again the values along with this whole criteria. Okay, so let's see another example. Cos pi by 2x. Okay, so again there is a compression because there is a change along the x-axis or the horizontal axis to the factor of pi by 2. Okay, so over here we need to check the period as well. 2 pi over pi by 2. So the period is 4. So we know about the cos x graph. That's in this form. But over here we need to draw with a period of 4 because the graph is of cos pi by 2x. So we'll show the period is 4 and starts from 0. All right. Let's see the next example, that is negative. Okay, that's the negative sign over here. Negative cos 2 pi x. Okay, so you have to see the reflection, you have to see the compression, and check the reader as well. You have to keep these three steps in your mind. Negative cos 2 pi x. So there will be a compression and a reflection along x-axis. 2 pi over 2, I'm checking the period over here, that's 1. All right. So it's good to draw the original graph so you can easily relate that with the next one. Okay, cos x is of this type. Cos 2 pi will have a period of 1. It's end up at 1. Starts from 0. And you have to draw the inverted form or the reflection of that negative cos 2 pi x. So that will be exactly in the, okay, but you want me to draw cos 2 pi x, that would be in this form, ends up at over here, and the reflection of that will be in this form. Negative cos 2 pi x. So let's check. second last example of the graphing trigonometric functions. So again, we have a sine function over here, sine x plus pi by 2. So there is an addition along the function inside the function, and that addition shows that we have to move the graph to the left side to the factor of pi by 2. So we know about the original graph sine x, that will be in this form. We have to move it to the left side to this midpoint. We know about this middle point, and over here we get this middle point. Over here we have to move it to this midpoint. Okay, sine x plus pi by 2 so that will start from negative pi by 2, ends up at here. So now it will ends up at over here. You just have to add the factors along with pi by 2 with 0, 0 with pi by 2, and pi by 2, pi by 2. Okay, let's see if we want to find that value. This middle point, this will be pi, and the next value, that will be the ending value of this whole circulation. That will be 3 pi over 2. All right. So in this way, we check this whole thing. So the last example of graphing the trigonometric function is of cos x plus pi by 4 negative 1. So there will be we have to move the graph to the factor of pi by 4 to the left side, and then move it downward to the factor of -1. All right, cos x plus pi by 4 negative 1. Okay, so we know about the graph of cos x. And we have to move it we know that this is the 0 and this is the pi by 2, this is the pi, and this is 3 pi by 2, and this will be the 2 pi. So we have to move it to the right side, and here will pi by 4 will lie. So this whole graph will change in this form. Okay, let me just write. Okay, so the graph will start from here, pi by 4. So next we have to see what will be the -1 will do. It will move your graph to the downward side. Okay, over here we have this one factor. We have to move this whole to the downside and see what will happen. Okay, we have moved this whole thing, and you can see the graph will be in this type of form. And over here, -1 will lie. Okay, So this is the whole graph of cos x plus pi by 4 negative 1. Oh, sorry, there is an addition over here. We have to move the whole graph to the left side, not to the right side, because in addition, whenever there is an addition inside the inside the function of x, the graph will move along the left side. So we know about cos x, that's in this form. We have to move it a bit to the pi by 4's point. Okay, we know about this point, that is pi by 2, and over here our pi by 4 will lie. So the starting of our R graph will start from here. Okay, like this, cos x plus pi by 4, because we need to move the graph to the left side. Pi by 4, and then we need to add pi by 2 to check the next point. That will be 3 pi by 2. Okay, over here we'll have that, but it's a negative, so we need to do it according to that. So pi by 4 will be the next point. And next we have to move this whole graph to the factor of 1 to the down. That will be in this form. Over here our negative 1 pi by 4 will lie, and this will be the middle point, and then the next point. So if we want to check the next point over here, you know that the next point will be that will be 3 pi by 4. And again, if we add 3 pi by 4 with pi by 2, we'll get the next value, that's lie over here, and then this, and then that.